summary video, a simple introduction to Python. If you don't want to download any software onto your computer, you can use Google Colab for this workshop. You do need a Google account, so you need a username and a password. You can see I've already logged in here. From the Google search engine, we simply look for Google Colab, which stands for Google Collaboratory. You see the first hit here is Welcome to Colab. So we click on that. Here are some of my notebooks. To create a new notebook, you just click on this blue button here. Okay, so I've already prepared a notebook. You can see I've saved it as a simple introduction to Python. The first cell here is what we call a text cell. And in this text cell, you can see I've put the exclamation mark, Loughborough logo, and then this is the URL for this image. To execute a cell, we simply hit Shift Enter. Okay, so there's our logo. We've got a title for our notebook. Again, this is a text cell. So if you use a hash, gives us a nice title. So we're calling this a simple introduction to Python. Again, to execute the cell, Shift Enter. If we want to insert images that we have on our computer, then we use these commands here. This image is called simplepython.png, and you can see I've dragged and dropped it into this folder on the left. So if we execute this cell, it gives us this image, which is taken from the brochure. So the aim of the workshop is to learn a high-level general purpose programming language, and at the end of the workshop, you'll be able to use Python as a powerful calculator, write simple programs, produce figures and animations, write professional looking notebooks, and incorporate programming into your research. And for any final year students or MSc students, you'll be able to incorporate this into your project dissertation. I've also loaded here the itinerary. You'll see I've dragged and dropped itinerary.png again from the brochure. So again, these are the commands. We set the width is 800, same width as above. So on day one, I'm going to introduce you to Python using it as a calculator. Then we'll look at the turtle library, plotting some pictures. We'll do simple programming after calculator. Then we'll look at the turtle library. And then it's a hands-on workshop, so I'll give you some simple exercises so you can, you can have a go at some of the problems and see what you've learned on the first day. On day two, I'm going to introduce you to numerical Python and matplotlib for plotting figures. Then we'll look at Google Colab and GitHub. GitHub is used extensively in industry. Then I'll show you how you can use Python for mathematics. And again, there are exercises to give you hands-on practice. On day three, I'm going to show you Python for business. So we will have a brief look at cryptography. Cybersecurity is becoming very important, especially in the business world. Then we'll look at data science, and we'll look at some examples from A-level mathematics. We'll look at 4 different data sets. Then we'll look at artificial intelligence in the afternoon. Again, artificial intelligence is becoming more and more prevalent in the business world. And then finally, we'll look at object-oriented programming. So to open up a new cell, we simply hover here, and you can see you can either open up a text cell or a code cell. We will open a code cell, and we're going to put in some BODMAS. So this is just using Python as a simple calculator. We call this BODMAS, brackets, order, division, multiplication, addition, and subtraction. If we hit the Shift key, you can see we just stay within the cell. So we're just going to do some simple addition and subtractions. For example, 1 plus 2, and then say take away 4. If we hit Shift Enter, then it gives us the answer. Or we can hit the play button. We can also do multiplication and division. So for example, 4 multiplied by 8, all divided by 2. So use the forward hash for division. Again, we can either hit the play button or hit Shift Enter. So 4 times 8 is 32, divided by 2 gives us 16. Okay, so that's and then for BODMAS, I'm sure you all remember from school, we can do things like 3 multiplied and then brackets, 2 take away 4. So remember, with BODMAS, we work out what's in the brackets before we do the multiplication. We can also work with fractions. So for example, we could do, say, 1/2 plus 1/3. Notice that we're also leaving gaps between the operators. And the simple reason for that is Python code looks pretty when we leave gaps. Okay, so this is an example in fractions. 1/2 plus 1/3 is approximately 0.8333333, etc. If we want the symbolic answer, if we want the exact answer, we have to load our first library. So from a library called fractions, we're going to import a function called fraction with a capital F. And then we hit the return key, not shift enter, just enter. And then we can do, say, fraction 1/2. And notice this is a function, so we use commas for the placeholders. So we do fraction 1/2 plus fraction 1/3. Okay, so this is called symbolic computation. So let me just put a comment in here again. So we use hash for comments. So this is symbolic computation, which is becoming more and more important throughout the realms of science. And you'll see we get the exact answer 5/6. Okay, so this number is not exactly 5/6. So symbolic computation is very important. We can also do exponentiation. So for example, 2 to the power 8. Notice we do not leave gaps with exponentiation. So this is exponentiation. Okay, or powers if you like. Exponentiation. So 2 to the power 8 gives us the answer 256. Just like your calculator, we also kind of have buttons in Python. So from the math library, we're going to import some functions. You may be familiar with the square root function. You're probably not familiar with the floor function. I'll explain what that is in a moment. And then we'll also look at the constant, say pi. Okay, we hit shift enter. And you see we've got a green tick, which means everything is fine. Because we've loaded the function square root, we can now, for example, ask what is the square root of 9. And we can hit the little play button or hit shift enter, and you see you get the positive answer 3. So this is like the third form of the square root. We can also define and for the floor function, for example, suppose we want floor of 2.3, and you'll see that this gives us the largest integer less than or equal to x. Okay, I'll give you a few seconds to think about that. We want the largest integer less than or equal to x. So we want the floor of 2.3, we want the largest integer less than or equal to 2.3. And the answer, of course, is 2. Now, just to give you an idea of the interactive nature of this workshop, suppose I asked you to find the floor of minus 2.3. Okay, again, I'll give you a few seconds to think about that. Okay, so we want the largest integer less than or equal to minus 2.3. And the answer is minus 3. Now again, don't worry if you don't understand that. One of the benefits of using Python is we can play around with it until we understand what these functions do. I'm sure you're all aware of what pi is. Pi is a mathematical constant. So that's number pi. We can use that, so we can define our own function. And this is one of the this is why Python is so powerful. We can define our own function, which is like adding a button onto our calculator. So we're going to define a function called area circle. I think you can all work out what this function is going to do. To define a function, we use the special word def, and then we have to end this line with a colon. When we hit return, Python indents for us. So we're going to return the area of the circle, which will be pi multiplied by r squared. Okay, so that is our function. We've defined a function. So now we can call that function. So suppose we want the area of a circle of radius, say 5. And if we hit return, then the area of a circle of radius 5, you can see, is 78.5, etc. Okay, so we've defined our first function, which it's a bit like adding a button on your calculator. Next, I'm going to show you how to do a plot. So to do a plot, we need to first of all import numerical Python, which is called NumPy, and we use the alias NP. Okay, so we use the alias NP for NumPy. And then what we also need to import matplotlib.pyplot. So this is another library, and we're going to use the alias PLT. Okay, you're probably wondering why don't we use plot, and that's because there is a function called plot within matplotlib.pyplot. We need to establish a vector of values for x. So we use the special function called linspace. So x is going to go from -2 up to 2, and we'll take 100 points to get a nice smooth curve. So this gives us a vector. So x is what we call a vector of values, which goes from -2 up to 2, and we'll have 100 points in there. Our function, we're just going to plot a parabola. So this is y equals x squared. Okay, and if you plot this will give us a parabola. I'm sure if you've done A-level maths, you'll know what a parabola looks like. Then we want a plt.plot. So within PLT, there is a function called plot. We simply want to plot x, the x values against the y values. So this is plotting one vector against another vector. Then we want a plt.xlabel. Will be the x label will be x, and of course then we need to do a y label. So we need a plt.y label, and that will be y. Then we're going to do a title, plt.title. So we're going to have a bit of LaTeX here. So we want y equals x to the power 2. Okay, this is called LaTeX. And I will introduce you to more of this during a proper workshop. This is LaTeX for professional typesetting. Then we want to save the figure, plt.savefig. So there's a function called savefig, and we're going to call it parabola.png. And we're going to dots per inch will set equal to 300, but you can change that. Make that whatever you want. And then we want to show our figure, so plt.show, and then we need empty placeholders. So we've now hit the little play button. Here is our parabola. Okay, now you can see the font size isn't very big, so let's change the font size. So we're going to do plt.rcparams. plt.rc, oh, and you can see it should be a capital P. Okay, it just try and help us. Google Colab helps us. So it's plt rc params, and then we're going to do the font size, font.size, and we'll make this equal to 14. Let's just see. So we can run this cell again, and you can see that looks a bit better with a plot with a font size of 14. Okay, so that's just to give you a general idea of what we do in the workshop, and I hope to see you all again. I think the workshop is the 15th of the 17th to the 17th of September 2025, so I hope to see you all there.